Hello guys, welcome to watch our video. Today, inshallah, we will complete the solution of worksheet 7. In the previous session, that is the last exercises which we solved. Today, inshallah, we will complete the answer of the sheet. As you see here, page 3, this exercise, in exercise 1, 2, 4, okay, in exercise 1 to 4, as you see, I'm sorry, wait a minute, okay, determine whether the function f of x approaches infinity or negative infinity as x approaches 4 from the left and from the right. Okay, in this case, I told you that is the reciprocal function. I want to find limit of f of x is the given function when x approaches to 4 from left. That is the first request. Second one, limit f of x when x approaches to 4 from right. Here, I told you before in the previous session, sometimes I need the sketch of this function to help me how to find the limit. But if you remember the sketch, you don't need to draw, but I help you how to think of the answer of this question. Look with me the sketch of this function. Look here, since the numerator is what? Positive. Okay, and the power of the bracket in the denominator is odd number, here odd. I have to find the vertical asymptote which will be at the zeros of denominator. Here, what is the zero of denominator, or what is the value of x which make the denominator 0 is 4. I write here 4. The vertical asymptote, I use what? Dot line, as you see here. Okay, vertical line. As I showed you before, positive and odd, it will be in the first and third quadrant. That is first quadrant, second quadrant, third quadrant, fourth quadrant, with respect to the vertical asymptote, not with respect to the y-axis. Okay, as we approach to 4 from left, as you see, f of x goes to what? Negative infinity. Negative what? Infinity. Here, as we approach to 4 from right, go with the curve. Here, as you see, this curve goes or increased without any bound. In this case, it means infinity. Infinity, it means the function increase without end. A negative infinity, it means the function decrease without end. Okay. Some of you remember the sketch of this function, and he doesn't need to draw it. No problem. But I help you to draw the function. Okay, let's use another color, blue one. Okay. Here, as you see, the numerator is what? A negative, and the denominator is it has positive odd power. Positive odd power. Here, as I showed you before, you have to remember the cases which I showed you in the previous session. Okay, here zeros here at 4. The zeros of denominator at which we have to draw what? The vertical asymptote. The vertical asymptote. A negative and positive odd power, it means I draw in second and in fourth one. Then you can use the sketch to find the limit. Here, as I told you, I have to answer these 2 questions at each problem, or for each problem. X approaches to 4 from left. Limit f of x when x approaches to 4 from right. Look here with me. As I approach to 4 from left, f of x goes to infinity. So it will be infinity. As x approaches to 4 from right, it means I'm going toward 4, but from the number which is more than it at its right. F of x approaches to what? To negative infinity, because it decreases without bound. Okay, here let's change the color. I'd like to use another color, green. Green color, it's good. Okay, for this one I need the sketch, but if you remember, you don't need to draw. Here, this one at 4 also, we have to draw the vertical asymptote. Since here positive, here even positive power, here 2, it means both of the two part of the curve of this function, it will draw in the first and second. To find limit f of x, but if you remember the graph of this function, you don't need to 4 from left. It means as I approach to 4 from left, f of x goes to what? Infinity. He asks you to write infinity or negative infinity. Limit f of x when x approaches to 4 from right. As you see from right, as I approach from right, f of x goes to what? Infinity. The last question here, that is a negative, and the power of the denominator positive even, it means the two curve of the function here at 4, it is vertical asymptote. I'm sorry because I draw very fast here in the first, second, and fourth. Limit f of x when x approaches to 4 from left, as you see, as I approach to 4 from left, f of x goes to what? Negative infinity. Limit f of x as x approaches to 4 from right, approach to 4 from right, f of x goes to what? Negative infinity. I think it's so easy, okay? It's so easy. Let's clear the drawing, okay, to solve that next question. Here, I think it's so trivial. In exercise 5 to 8, determine whether f of x approaches infinity or negative infinity as x approaches to what? Negative 2 from left and from the right. I think it's so easy. I don't need to draw the sketch, but it is already given. I have to use it, okay, with me. Look here. Here, as x approaches from left, f of x goes to what? Look here, the curve of the function goes, but never intersect the vertical asymptote. The curve of the function never intersects the vertical asymptote. Okay, I write limit f of x when x approaches to negative 2 from left. The curve of the function goes to infinity. Limit f of x when x approaches to negative 2 from right. Here I approach to 2 from right. F of x goes to what? Infinity. As you see here, it will be infinity. For the other one here, that is negative 2, I ask limit f of x when x approaches negative 2 from left. Limit f of x when x approaches negative 2 from right. From left, as you see here, go with the curve, but very close to what? At the left of negative 2, but not from here, at the left of the curve. No, at the left of negative 2 from here, and to go with it, go or increased, okay? Increase without bound, okay? So it will be infinity. As we approach, x approaches to negative 2 from left, go with the curve. Look here, I'm here, go with this curve. It goes to negative infinity. Decrease without any bound. In this case, it means it goes to negative infinity. Look here with me. I have to complete clear first. Okay. By the same way, I answer the same question. Here, find as x approach to negative 2, limit f of x when x approaches to negative 2 from left, limit f of x when x approaches to negative 2 from right. Here, from left, f of x goes to what? Positive infinity. As we approach to negative 2 from left, the f of x goes to what? Negative infinity. Okay. Here, by the same way, I have to answer the same questions on for each problem. I'm sorry, x approaches to negative 2 from left, limit f of x when x approaches to negative 2 from right. Here, negative 2 from left, f of x goes to negative infinity. I think it's clear and so trivial, this question, as we solve it in exercise. As we solve it in the session. Goes to what? Infinity. Clear? And you have to focus with me because I'll explain. Maybe you learned it like this one before, but I know most of you forgot how to solve like this problem. Okay. Look here, grade 12. Determine the equations of the vertical asymptote, maybe asymptotes of the graph of each function. Here, how to find this? You have to know what is the meaning of vertical asymptote. It is a vertical line at which the curve of the function goes to infinity or negative infinity. Okay, the curve of the function never intersects this vertical asymptote. How we get the equation of vertical line? The equation of vertical line x equal constant. Equal what? Constant. That is the equation of any vertical asymptote. How we get this equation? It means the values of x which makes the denominator 0 after we simplify the function. I have to make sure the function is in the simplest form before finding what? The vertical asymptote. Let's solve the first question. As you see, this function in the simplest form because I can't put it in another form such that there is no any common factor between numerator and denominator. Here I can factorize the numerator because it is already in the simplest form and also the denominator. In this case, after we make sure the function is the simplest form, equate the denominator by 0. If we divide here by 2 and here by 2, it would be x plus 1 equal 0 implies an x equal negative 1. That is equation of vertical asymptote. Here, f of x, okay, has what? Vertical asymptote at x equal negative 1. Some of you would, they asked me today, Miss, where is 2? Okay, I divide both equation by 2 to cancel. By another way, number multiply bracket equals 0, the number impossible to be 0, so the bracket it will be what? 0. Some others can distribute 2x plus 2 equals 0. It means solve by any way. I have many ways to solve. Okay? Please again, to find the equation of vertical asymptote, I have to make sure the function in the simplest form by factorizing the numerator and denominator, okay, and simplify the function. After we simplify, we equate the denominator by 0. Let's solve the next question. Here, this one. X squared plus 1 means that is the sum of two squared values. That is the squared value, squared value. We don't have any factorizing for this one. Even if you use the calculator, it will give you math error to find. Or it will give you, not math error, imaginary number, but as real, we don't have. That is the difference between two squares. Here x and here x. Minus 1 plus 1. Okay, factorize the numerator, factorize the denominator. Okay. Miss, do you have any brackets in numerator and denominator to cancel together? No, I don't have. This means this function in the simplest form. After I make sure the function in the simplest form, what are the zeros of denominator? What is make this denominator equal 0? X equal what? 1. If x equal 1 will give you this bracket will give you 0, or what? X equal negative 1. That is the equation of what? Vertical asymptote. Okay, you find the zeros of that denominator after you make sure the function in the simplest form. Please, this is a very, very important note. Okay, that is what? Vertical asymptote. Okay, at x equal 1 or at x equal negative 1. And not or, but because I have two vertical asymptotes. Okay, and I have x equal 1 and x equal negative 1. Here, let's solve the next problem. Okay, look here. For part C, I have to make sure the function is the simplest form or no. As you see, the numerator cannot be simplified, factorized. It's already cannot be factorized, and this one, in this case here, x squared plus 1 equals 0. It will give you what? X squared equal what? Negative 1. Impossible. Okay. Clear? Impossible to be 0. So there is no what? Vertical asymptote of this function. Clear or not clear? Wait. Okay, as you see, x squared equal negative 1. Impossible to square the value. Sorry, I didn't complete here. Okay. I'm sorry. Impossible. Okay. There is no vertical asymptote. Let's solve this one. Factorize the numerator. Factorize the denominator. Okay. X, and you can use the calculator. Multiply 3. Here x minus 2. Here what? X plus 2. I think I know most of you know how to factorize. Look here, I'd like to use a different color. Okay, use the red. Now, as you see, this one common, like this one, I will cancel. Okay. I told you I find the vertical asymptote after we simplify the function. The new function, it will be x plus 4 over what? X plus 2. Now I can find the vertical asymptote. What is the zeros of denominator? The denominator equals 0 at x equal what? Negative. I find the vertical asymptote by finding the zeros of denominator. What is the zeros of denominator here? X equal negative 2, the vertical asymptote. Okay, as you see, But Miss here, what is the value at x equal to? Here that is the factor we cancelled from numerator and denominator. Add the zeros of the factor that we removed or we cancelled, we have whole. Here at x equal to the zero of the second factor, we have what? Whole. What is the meaning of whole? As you know, at whole we have removable the what? Discontinuity. But as you see at vertical asymptote, we have non-removable discontinuity. Because as I told you before, any rational function discontinuous at the zeros of the limit. At the zeros of the limit. But as you know, the discontinuity, we have two types of discontinuity. Removable discontinuity, this occur at the hole or gap, okay? But the non-removable discontinuity occur at what? At vertical asymptote and at the jump, at jump. Here, as I told you, I find the vertical asymptote, the zeros of by finding the zeros of the denominator after we simplify the function. This non-removable discontinuity. But the other zero of the denominator at which we cancel or we cancel from numerator and denominator, we have whole or we name it removable discontinuity. Okay, I hope you understand everything in this video. In the next video, inshallah, we will complete the solution of this worksheet number 4, which will be limits at infinity. Okay, thank you. I hope you understand and have a nice day.